Yes, class. Am I audible? Okay, Aisha. What about others?
Yes, Miss, you are audible.
Yes, ma'am.
Okay. So, Hiba, this is your first class, right? Hiba Ghazali?
Yes.
Okay. Hiba. See, we have completed and we have started with actually circular motion. We have not completed it yet. Most probably by today's class or the next class, we'll be able to complete with this lesson. We are currently doing laws of motion. So most of the terms we have discussed, Hiba. So I think you will be needing a backup class of circular motion as well. And the class, we couldn't have the class on Friday. So I hope you all got the information. And I didn't know that you all had the mathematics class on Saturday. That's why no other class could be arranged. So the timings for now, the next coming Friday or any other class that we'll discuss together. Because I didn't know that you all had your maths class as well. So these timings I had informed though that we were going to have a class. I hope you all were informed, or was there any student who wasn't informed before the class began? So I think Talha also you were having some confusion also regarding the class. Talha, we didn't have the class on Friday. Fine.
Okay.
So since maths class was there, so that's why the class couldn't be postponed to Saturday or Sunday. Your Imad's brother?
Yes, ma'am.
No. Fine, class. Let's just complete with this topic, circular motion, and then we can start with a fresh topic. See, certain things let us revise before we begin. Hiba, it can happen that many things you'll not be able to understand. Hiba, just tell me one thing. What's the physics lesson that is going in your school? How much lessons have been completed in the school?
We finished laws of motion and we
Energy, and power.
Yeah, we finished that.
You have finished. Okay. Okay, fine. So, see, we have not started with work, energy, and power. So, I hope by the next week or by the next class, we will be able to start it because maximum part has been completed of this lesson. Backup timing, again, now, Hiba, you'll also be added in the backup timings that we'll discuss later on. On Wednesday's class, we'll discuss it. And next week, all those students who have attended the class of circular motion, I think maximum of you are there from circular motion at least, Waziha and all, I think you all have attended. So next Monday, what's next Monday? It's, I think, 24th. So 24th of October, you will be having a small class test within the class duration itself. Fine. So whatever we have studied, basic questions, 2 to 3 questions will be asked from it. Now see, non-circular motion we were discussing. In case of non-circular motion, velocity can be variable, which provides tangential acceleration. Tangential acceleration is simply rate of change of velocity. You write it as dv over dt. That's the formula of it. That's the definition of it. When the direction of velocity changes, because of that rate of change of velocity, we obtain centripetal acceleration. So centripetal acceleration also we had seen, which was v square divided by a capital R, means velocity square divided by the radius of the circle, and its direction is along the radius towards the center. Then if the magnitude of angular velocity changes, you get angular acceleration. So that is given by rate of change of displacement, d theta over dt, or change in theta, that is the angular displacement by angular time. That gives you angular acceleration. Angular acceleration is rate of change of angular velocity. That is d omega over dt. You can say, or delta omega over delta t. This we had discussed, and direction of omega remains constant because it acts towards the center. So if it is acting towards the center, we had noticed the fact that if it is acting towards the center or any other point or axis of rotation, its direction cannot change. So if nothing changes, if no change is occurring in the velocity, then there will be no acceleration. So majorly 3 types of accelerations we had discussed: centripetal, tangential, and angular. Now see, angular acceleration was a separate topic that we have already covered. Angular accelerations questions will also be separately from there. But if your linear velocity is changing, then tangential acceleration is also acting, centripetal acceleration is also acting. Then how will you write the resultant acceleration? The question is, magnitude of V is changing, you're getting tangential acceleration. Direction of V is changing, you're getting centripetal acceleration. So two kinds of accelerations you are obtaining. So if you are asked to write the rate of change of velocity, then you cannot specify that magnitude is this, direction is this. This was just for your understanding. How will you write if two accelerations are provided? So that let's just complete with it. I think that we couldn't complete in the last class. See, if total acceleration is asked, total acceleration in non-uniform circular motion. Total acceleration, you can say, or you can say net acceleration that is coming. See, how will you write it? Direction of tangential acceleration, we had seen that it was tangential. Whatever was the linear velocity, similarly, it was tangential to it. So if tangential acceleration is like this, this is what? This is your tangential acceleration. If this is tangential acceleration, centripetal acceleration will point at which direction? So centripetal acceleration we had studied along the radius, and which direction? Towards the center. So this is centripetal acceleration. Are you able to notice that parallelogram's law can now be valid? It's now applicable to this. You have two vector quantities. Accelerations are of two types right now. So if you have two vectors which represent the adjacent sides of a parallelogram, then the resultant of the two vectors is given by the diagonal of the parallelogram. So it means if I want to find out the resultant of this, it will point somewhere here. If you complete up this parallelogram, this will be the net acceleration. Or even if you write it in the whole complete formula for the net acceleration, that is AC square plus AT square plus 2AC into AT into cos theta. So clearly you can see angle found between centripetal acceleration and tangential acceleration is 90 degree. So this term, since this is cos 90 degree, this term becomes 0 directly. If you have this term as 0, then how will you write? Acceleration, simply acceleration will be centripetal acceleration square plus tangential acceleration square under root. And class, this part was, though this was left in the last class, but this is a very important part because maximum questions from accelerations due to change of linear velocity come from this part only, because it combines both of your accelerations. Only a single question can be given to you where both the accelerations will be involved. One more thing that we have already studied, I think Aisha must be able to relate it because we have done it. If this is beta, then see, how do we write tan beta? Tan beta will be simply, if we write this as tan beta, so this is the perpendicular, which is represented by AC, and this is the base represented by AT. So if you want to know what's the direction, you can take the ratios and find out and write it as beta is tan inverse, whatever angle you are obtaining. Or if you are obtaining a proper value, then you can write it. Clear? So basically, this is just two vectors. You just have to remember tangential acceleration is along the tangent and centripetal acceleration is along the center. So both the vectors are making an angle of 90 degree. And if two vectors make an angle of 90 degree, clearly the result is this. So if net acceleration is asked to you, speed will be given to you. With the help of speed, calculate tangential acceleration. If radius is given to you, with the help of speed and radius, calculate centripetal acceleration. And then calculate the resultant or net acceleration. Understood? This is clear, just the resultant of two vectors we are doing. Do one thing, this will become clear with the help of question only. Start noting this part. I'll write down a question, then copy the question, then we'll discuss it. Is Abdullah present? Muhammad Abdullah. Yes. Abdullah, you were having certain doubts, no? I had received a message from you. Was it you who were having doubt? If you had any doubt, just let me know. Okay. Then I'll discuss the timings. If you wish, Abdullah, you can do one thing. You can send the questions on WhatsApp also. Do you have my number? I think I had sent you the number for the test papers. No, so you can do one thing. You can send your questions to me on WhatsApp. Then I can arrange a class also for you, or I can send you the solutions also on WhatsApp. Let me know whatever kind of doubts you have. If you have doubts specifically in certain numericals, then this can be done. If certain topic is there, then we can arrange a class. See, the question says a body is moving on a circular track with a speed of 1 meter per second. So circular track is there. The body is moving with a speed of 1 meter per second. The radius of track is 2 meters. So the radius of this track is 2 meters. It says if its velocity changes at the rate of 2 meter per second square, you have to calculate centripetal acceleration, you have to find out total acceleration. See class, this linear velocity is given to you as 1 meter per second. Now, what type of acceleration is this? Why aren't we saying that this is a centripetal acceleration? Why is the question referring us or asking us to calculate the centripetal acceleration separately? Reason is that this is if the velocity changes at rate of 2 meter per second square. Rate of change of velocity, how do we calculate? Tangential acceleration, dv over dt. So dv over dt is given to you as what? This is given to you as 2 meter per second square, because the rate of change of velocity is 2 meter per second square. So if rate of change of velocity is given, it means dv over dt is given. And what do we say dv over dt? That is tangential acceleration. So yes, centripetal acceleration's calculation is very easy. Can anyone tell what's the answer for centripetal acceleration? It's simply v square divided by r. V is also there, r is also there.
One.
Yes, someone was answering. Waziha was answering.
Yes, ma'am. 1 meter per second.
See, 1 meter. Okay, for the calculations, no, do one thing. Make this as 10. Now I think calculation will become easier. So velocity, I have changed it to 10 meter per second. Now can you all answer? See, velocity is this, radius is 2 meters. Fine. Now put this into this formula. See what you are the answer you're getting. Maha, now you also
50.
change your answer. Yes, Aisha. Perfect. It will be 50. See, 10 into 10. Yes, Maha. Because 10 into 10 will give you 100 divided by 2. So that is 50 meter per second square. So this is centripetal acceleration. And what is tangential acceleration? Yes, class. Yes, Yusuf, what is tangential acceleration? I've just discussed it now. Talha, can you answer? Tangential acceleration in this question. Waziha?
Ma'am, it's 5.
No, see, tangential acceleration is this only. That's what I was discussing with you all. Velocity changes at rate of 2 meter per second. It means this is saying rate of change of velocity is 2 meter per second square. Fine, agreed? It is written in the question that its velocity changes at rate of this. What do we write dv over dt? In the last week, we have been discussing this only, that centripetal's acceleration formula is this, while tangential acceleration's formula is this. So it means if dv over dt is given to you as 2 meter per second square, then rightly you can say tangential acceleration is this quantity. Now, is this clear to all of you? Waziha, Talha, Yusuf?
Yes.
Clear? Yusuf, are you there in the class? Okay. So this is 2 meter per second. So right now only a formula we have discussed to get the total acceleration. Total acceleration is simply under root AT square plus AC square, which is under root 50 whole square plus 2 square. So that will be 2500 plus 4, 2504 under root. This will be total acceleration, this much meter per second square. Also, you can never leave the answers of vector just like this. You have to mention the direction always. So direction also we had discussed that it will be AC divided by AT. Centripetal acceleration is 50, tangential is 2, that becomes 25. So beta is tan inverse 25. This is a complete answer for you. You will write the total acceleration is root under root 2504. Even this will be around 50 only. You can approximate and write the answer as 50 meter per second square. So acceleration is 20 under root 2504 meter per second square. Along the direction, beta is tan inverse 25. This is a complete answer for a proper vector quantity. Fine. So note down this question, note down the solution. Question I hope you all have written. Okay, so see class, this was all about the kinematics of circular motion. I had told you that we study any motion in two parts. You have kinematics and you have dynamics. The way we had motion in a straight line, motion in a plane as kinematics. And when we reach dynamics, then in case of dynamics, we study the cause. In case of kinematics, you are just concerned with the motion, that the body is moving, acceleration is acting, displacement is there, velocity is occurring in the body. You're not concerned with what is causing the motion. But as you reach dynamics, like this lesson, laws of motion, this completely deals with it connects you with the causes of motion. You come to know about force. Similarly, in circular motion also, circular motion, kinematics, we have seen all the angular velocity, angular acceleration, linear velocity, and everything that acts. But the force that drives your acceleration to occur, or the force that comes as a result or consequence of the acceleration, that we'll study. So last topic that is left from this lesson is dynamics of uniform circular motion. From here, you have certain applications also, bending of cyclist and all. So this deals with dynamics of uniform circular motion. So first thing that you have to understand is centripetal acceleration is there, a force will definitely be there, and that force is known as centripetal force. Not a single force, you have two forces, centripetal force and centrifugal force. Both the forces are there in your syllabus. Centripetal we'll start with and centrifugal force will come after this. Now, what is meant by centripetal force? See, in very, very simple terms, no, centripetal force is what? It's simply the force that is required to change the direction. Centripetal acceleration came by? Centripetal acceleration came as a result of change of direction of velocity. So if the direction, whatever the force is needed to change this direction of velocity in a circular motion, that is known as centripetal force. So it's the force only that provides the centripetal acceleration. Formula will be the same. Whatever Newton's second law of motion was there, what we have studied in case of Newton's second law of motion, that will be the same here, because Newton's law is applied over here also. But the meaning is changed over here. Centripetal acceleration is different. Centripetal acceleration is different from linear acceleration. It acts towards the center along the radius. So centripetal force is the force that causes the centripetal acceleration. Basically, in simple words, you can say it is the force that is required to change the direction of velocity. At every point, see, this point I have chosen M. This is the center O. So centripetal acceleration acts and the linear velocity is there. So some force is required not to change this direction. If you change the direction of linear velocity, then only at this point you will be able to obtain this, then at this point you will be able to obtain this. So this force that is required to change the direction of velocity, that is called as centripetal force. So since it is causing, or it is required to provide the necessary centripetal acceleration, you write it as the direction becomes acting along the center towards the radius. So centripetal force also acts towards the center along the radius. Now see class, one important thing. Centripetal force in reality, it is not an actual force that is present. This is not a separate force. Centripetal force is provided by some other forces that are present. That let's discuss. Before, let me write down these points which I have mentioned. That is very important point that we have to discuss right now, because centripetal force will come, it will keep on coming, and especially students who are preparing for their entrances after class 12. Centripetal force application you will have to know by your own. So if you get it clear in 11th class physics only, then after your 12th and for your entrances of JEE and NEET also it is helpful, because in many questions it is there. So this is the force. It's actually not a force, it's a requirement. So force required to change the meaning. And why am I writing this force? I'll get it clear right now. To change the direction of velocity and it provides centripetal acceleration. Its direction also will be the same, acting along the radius towards the center. So it acts along the radius and formula is very easy. See, if a body is there whose mass is a, acceleration is centripetal acceleration. This is just the formula, and we all know what's the formula for centripetal acceleration. Right now only we have done it. That is v square by r. So this becomes the formula. If you wish, you can write this in terms of angular velocity as well. So formula for centripetal acceleration is not difficult. Why? Because here you know, here your force is equal to mass into acceleration. Acceleration's formula you already know, v square by r. So centripetal force's formula is not difficult. But now see class, till here the portion was not tough. You must have understood till here. Now the part that you will have to understand is very important. So pay attention, and wherever you're not able to understand, interrupt me in between. You can even text me in the chat box, because that is, I think, the most comfortable place to write your queries, or you can unmute yourself or directly ask me. See class, constantly I'm saying it's a force required to change direction of velocity, force that provides a centripetal acceleration. This force that I'm mentioning, this is not an actual force that is present. It's just some other forces in nature provide you the necessary centripetal force. For example, this will only be cleared by an example. Let's take the example of planets which are revolving around the sun. Take this example. Planets revolving around the sun. Planets revolving around the sun. See, planets revolving around the sun. See class, now what will happen? This is, let's say this is some planet, not specifically mentioning any name of planet, any planet is there. This is sun. Now what will happen? If circular motion is occurring, few things will be there. Few things will always be there. Those things will remain common, and that is acceleration will come tangential. Acceleration will there even in the rotation of planets that are occurring in the space. Same phenomena, because the circular motion is there, are occurring. So see class, now what will happen? This planet will keep on revolving around the sun. So some force will be there, which I have mentioned you, that is the centripetal force. It will act. Now coming to the point, centripetal force exists or not. So yes, centripetal force actually does not exist. It's some other force that compensates for this. So this has to be the centripetal force, what we have studied. According to what we have studied till now, this has to be the centripetal force. But C class, now this there, if two planets are there, if two celestial bodies are there, let's say this planet is there and the sun is there, in between these there will be a force of gravitation. Gravitational force will exist. So, and direction of gravitational force will be between these two objects. So see, now in this case, the necessary centripetal force is being provided by the gravitational force. So this mv square by r is a generalized formula. We have not done gravitation after your rotational. The last lesson of your first book is your gravitation only. There you will see that the formula is gm1 m2 divided by r square. You will see this is the formula of gravitational force. So you will equate this to mv square by r, because mv square by r physically has no meaning. Physically this term has no meaning. FC, that is centripetal force, that is like a demand. Some requirement is there. So some other forces which are actually present in nature, which have the physical meaning and which bring out actual meaning, they compensate the work of these. My voice is not audible. Am I audible or my voice is still cracking, class? Let me know. Is it fine now?
Yes.
Okay. Let me know if my voice is not audible. I think, okay. I think was here, just check your connection also once again, because other students are able to hear.
Okay, ma'am.
Oh. Or let's take one more example. That why centripetal force is, it's just like a criteria that somewhat this is the requirement for any force, and some other force that are present in nature, they are actually present, like gravitational force actually exists. We can never say that gravitational force is just a criteria or it's just a hypothetical force. No, gravitational force actually exists. So in case of rotational motion around planet, necessary centripetal force is provided by the gravitational force. One more example. Nucleus is there. Around this nucleus, where protons are lying, electrons are present. So between this, you will study in class 12. In detail, you have your first and second lessons. That is your first unit of electrostatics. So that time you'll study it in detail. Right now, briefly, if electron and proton is there, electron and protons are there. So see, in between both of these, there will be presence of electric force. Electric force, you can say, electrostatic force, you can say. So see, when the nucleus will be there, electron will be revolving around the nucleus. Fine. So if electron is able to revolve around the nucleus, circular motion is there, all the phenomena will come. Acceleration, your centripetal acceleration, centripetal force, everything will be there. So if electric force is present, so this electric force will now provide the centripetal force. So in this case, electric force provides centripetal force. One last example, let's take. So if you have any doubts that time, I hope it will become clear. For example, let's take a circular track is there. Suppose, just imagine at this point, a car is there at this point, and this is a complete circular track. Means the road is in the form of a circle track. So a car is moving. What will happen? The car will keep on moving. This we'll study also. The frictional force acts towards the center in the case to avoid the car from slipping. Fine. Otherwise, the car would have slipped. So this time the necessary centripetal force is provided by what? Here in this case, friction provides a centripetal force. So you can say if you say what is actually a centripetal force, it provides you acceleration. So it means if I'm saying centripetal force provides acceleration, friction in this case provides acceleration. Gravitational force in that case provides acceleration. Electric force in that case provides acceleration. Now tell me, understood this point or not, that why centripetal? Because I think above part is very easy. F is equal to ma. From there you have the formula mv square by r. But this part, that all the forces are providing necessary centripetal force, and centripetal force physically has no meaning. This is clear to all of you or not? Or any queries, let me know. Clear or not? Yes or no?
Yes, ma'am.
Okay. Yes, Talha, clear?
Yes, ma'am.
Okay. Hiba, are you able to understand today's class?
Yes, ma'am.
All right. Okay then. So let's do a numerical also, very basic numerical. Let's do, then you can note down this part. Let's take a very just basic numerical so that we are familiar with the formula, because formula we had stopped. We were focusing now on this part first. Now I'm coming back to the formula from where we had stopped. F is equal to mv square by r. So let's take a body of mass 10 kg is moving on a circular track. So as soon as the term circular, see class, some of the questions are actually a part of your rotational physics, rotational dynamics. So that time we are just thorough with circular motion. So whatever portion was of circular motion is included in laws of motion. In laws of motion, you actually just have that bending of cyclists and resolution of vectors and friction and normal reaction. Fine. I have combined all the circular motion that is present in your syllabus. So circular motion entirely is over. So when we'll do rotational physics, rotational dynamics, rotation of motion, that time we'll not do circular motion, because maximum part we have covered. So whatever things that will get related, like torque and all these forces come, that only we'll do. So circular track, let's take the radius as 5 meter of radius 5 meter. Fine. With velocity of 2 meter per second. Calculate centripetal force. So direct formula. Yes, mass is 10 kg. Radius is 5 meters, and see, velocity is 2 meter per second. So centripetal forces formula is mass into centripetal acceleration, and centripetal acceleration is v square by r. Yes, very quick, Maha. Correct. Mass is 10, velocity is 2, so it becomes 2 into 2 because it's the square of v, divided by r. R is 5. See class, this 5 cancels this 10, you get 2. 2 cube, you directly get it as 8. And yes, Maha, SI unit. Yes, your magnitude is right. Maha, SI unit. What's the SI unit of force?
Newton.
Newton. So this will also be Newton only. Okay, Maha. So when you're writing 8, do mention it as 8 Newton. This is also force, no? Centripetal force, gravitational force, all these forces will ultimately at the end also, whatever type of force you're dealing with, ultimately it will have the unit as SI unit as Newton only. And CGS unit is 9. One more thing class, before you copy down this part, no? One part that is related with this. See, centripetal force we have done, which is acting towards the center. If I say this is the body present, fine, and a force is there, which, see, if a centripetal force is acting towards the center, means whatever is this force, gravitational, electric, friction, any of the forces that are present in nature, nuclear force can be present, any force can be there. See, class, according to Newton's third law of motion that we have studied, action and reaction exists. So how can we leave? See, this is not actually a reaction, but in order to maintain the system in equilibrium, not exactly, this is not a reaction, firstly, not a reactional force, but one force acts away from the radius as well. This force is known as centrifugal force. You must have experienced this. There's a ride that merry-go-round. What do we call that ride? There's a circular disc is there and a stand is there and that is rotated and we sit on it. So there's a ride, no, merry-go-round, I think we say. So even if you are holding the handle and you're moving along with that disc, with the plate which is holding you, then it's fine. If you leave that disc, that stand, and you are on the plate when the merry-go-round is moving, if you will leave, you will be pulled and you will fall onto this direction, away from the radius of it. This is because centrifugal force is acting now and it is putting you. So centrifugal force acts only in a rotating frame. Acts in a rotating frame. So it's not actually a force, it's a pseudo force, which we say, means this is a force that is just present. The way, see, centripetal, if centripetal force is not an actual force that is there, so how can we say centrifugal force is present? So a term we have, as we have discussed also once, that this is known as pseudo force, whose formula is mass of body into acceleration of body, that will be fixed. Direction is different. Direction of centrifugal forces along the radius, but away from the center. Along the radius, but away from the center. And class, formula will still be the same. Formula of this is because it's a pseudo force, and pseudo force is mass of body into acceleration of body. Formula is same, and you'll not be using centrifugal force much in just the application questions, no, where you have like this example only of the ride merry-go-round. Such types of questions have this application. Otherwise, maximum numericals are from your centripetal force. Other forces will be present in nature where you have to equate it with mv square by r. And one more thing, class, it is not a reaction of centripetal force, because do not think that if this is acting towards the center, this is acting away from the center, so they are action reaction forces. They are independent forces. It's a coincidence that their directions are exactly opposite to each other. They have no relation with them. Direction is opposite, that's why centripetal means that something that is pointing towards the center. In biology also we have this term centripetal. If something that is pointing towards the center, something that is going away, we see that is centrifugal. All right, class. So I think now we have completed a big portion. Centripetal force is an important topic. Write it down. Any queries you have in between while writing, let me know. But this is an important part from dynamics of circular motion. C class. So one more thing, you have two applications based on this. Bending of cyclist you have, and yes, banking of road, that when the inclination comes. So that we'll see. So as I've told you, 24th you'll be having a test, most probably 24th or the Wednesday that is coming, 26th, neither of these. Before that, see, one small topic let's do. At least let's complete with bending of road, because it's very, very small and derivation is also very easy. One thing before that, just understand the safe limit. Safe limit means if velocity is exceeded, for example, a circular track is there, bent circular track is there, mass of the car is there, velocity is there, this is the radius, fine. So safe limit means the maximum velocity with which the car can cover the circular track. Maximum velocity with which body can move on circular track. Now problem is, if this velocity is exceeded, if this velocity is exceeded, then the car can skid. In the sense, it can occur certain translatory movement. If this velocity is exceeded, car will skid. So that's why certain safety limit has to be followed. So the bending of road is done in that way only. Bending of road, this part is easier, in the non-inclined part. Let's complete that and then we'll stop. Bending of road. This is the curved path. Suppose here you have your vehicle. This part is having your vehicle. Then see, normal reaction will be present over here. M into G will be there. Gravitational force, as we have discussed. Since it is on the contact, normal reaction will be upwards. This will be here. A centrifugal force. A centrifugal force will act outwards and frictional force will act inwards along the radius towards the center, because it has to oppose. Frictional force works as what? To oppose it. So friction opposes centrifugal force. Fine, frictional force exceeds or opposes centrifugal force. So it means centripetal friction is providing the centripetal force. So you can say the necessary centripetal force is now provided by friction. mv square by r is formula of the centripetal force. Friction is mu n. From here, if you write the value of n, normal reaction, by looking at the figure, you can directly say this is what? This is m into g. M gets cancelled. What is the value of v that you're getting? V is coming out to be. This is actually less than or equal to under root mu r g from here. Why less than sign we are including? Because safety limit is there. This has not to be exceeded. The rest of the things remain fine. All right. So this was a very small derivation. Questions we'll do in the next class only. You all can note down this. Aisha, do you have your class today after this?
Yes, ma'am.
Which subject do you
After
have
like
now?
10 minutes.
Yes. After 10 minutes, you have which subject?
Bio.
Okay,
Bio.
bio is there. So other students do also take the same subject? No, Yusuf, just a small derivation is again left from here and a little numerical practice. So that will be, this chapter will be completed in the next class and test will be in the next week. If I think Monday, we can have a holiday. If we have a holiday on Monday, then your test will be on Wednesday. If the class is there on Monday, we'll be having the test on Monday, whenever will be the next class after Wednesday. So Wednesday we'll discuss the rest of the things, and then I think on Wednesday only, since a half an hour part is left. So on Wednesday only, we'll try to start with work, energy, and power. All right. So note this down. Any queries you have, let me know. And Aisha and other students. Maha, do you also take biology here?
No.
Just text me done in the chat column once we have completed. Aisha, you can take the screenshots also and you can leave because at least have a break of 5 minutes before attending the next class. Yes, all those who have completed, you all can leave. Class is over.
Ma'am,
Yes, Hiba.
ma'am, when will the next class be?
Next class will be exactly on the same timings on Wednesday. So 2 classes are there, Monday, Wednesday. And regarding the backup timings, that I'll discuss you on Wednesday directly.
Yes, ma'am.
Okay.
Okay. Thank you, ma'am.
Thank you so much.